Hey everyone, Emily here, and welcome back to the channel. Today we're diving into the hidden world, a microscopic universe that exists inside your seemingly simple glass of water. What secrets does it hold? We use water every day for everything from drinking to cooking, but have you ever stopped to wonder, what's really, truly in it? What are we actually consuming? Even the clearest, most pristine-looking water can hide invisible contaminants, tiny organisms, minuscule particles, things you can't even imagine are there, and even dissolved chemicals. Our bodies are mostly water, making up a significant percentage of our being, so what's in our glass directly impacts our health, our energy levels, and our overall well-being. If you were to take just a single drop of ordinary tap water and put it under a powerful microscope, you might be surprised to see living organisms teeming with life, dust, rust particles flaking off from old pipes, or various dissolved chemicals that are invisible to the naked eye. Now, most water treatment plants really do work hard and do a great job at cleaning our water, but sometimes, despite their best efforts, contaminants can still sneak in, especially through aging and corroded pipes. That's precisely where having a home water purification system comes in handy, giving your water that extra layer of protection, an extra safety check for your peace of mind. Today, we're going to explore the cutting-edge tech and innovations that keeps your water not just clear, but truly clean, safe, and healthy for you and your family. So, what are the main threats lurking, unseen, hiding in our tap water right under our noses? It's a question we should all be asking. First, biological contaminants, bacteria, viruses, and parasites, a microscopic world of organisms, germs that can make us sick, sometimes with serious consequences. These often come from sewage or animal waste, finding their way into our water supply, and while city water is disinfected at treatment plants, a crucial first line of defense, some resilient organisms can still survive the journey through miles of pipes to your tap. Next, we have heavy metals like lead, a notorious contaminant, mercury, a potent neurotoxin, and arsenic, a known carcinogen. You can't see or taste them, making them particularly insidious, but they can leach from old pipes, especially in older buildings, and build up in your body over time even at low levels, causing serious health issues from developmental problems to organ damage. Then, there are chemical contaminants, pesticides used extensively in agriculture, herbicides designed to kill unwanted plants, and industrial chemicals, byproducts of manufacturing processes that run off into water sources, polluting rivers, lakes, and groundwater. Even chlorine, used to disinfect water and kill harmful bacteria, can affect taste, making water unpleasant to drink, and may have health risks with long-term exposure, leading to concerns about disinfection byproducts. Finally, we have physical contaminants, sediment and rust, visible particles that affect water clarity, make water cloudy and can clog pipes, reducing water pressure and damaging appliances. Though they're generally less dangerous than germs or metals, they still impact water quality. All these contaminants from various sources, biological, chemical, and physical, pose different risks and require different solutions. Are why we need smart ways to clean our water and ensure its safety. Water purification is about building barriers, multiple lines of defense to keep these bad guys out of your glass and protect your health. Understanding what's in your water, knowing the specific threats you face, is the first step to protecting your health and ensuring the well-being of your family. That's why we use different filters and purifiers, each designed for a specific purpose, each targeting specific threats, from sediment to microscopic bacteria. Let's see how these technologies work together to give you clean, safe water. Ready to meet your water security team and learn how they protect you? Let's dive into the world of water filtration, starting with mechanical filtration, the first line of defense in keeping our water clean and safe. It's a crucial step in ensuring the water we use every day is free from visible impurities. Think of sediment filters as your trusty kitchen strainers, but on a much finer scale. They work by physically blocking and catching sand, dirt, rust particles, and other larger sediments that can cloud your water. This process helps to make water clearer and more visually appealing. They're simple in design, relatively inexpensive, and incredibly effective, and play a vital role in protecting more delicate and expensive filters downstream from premature clogging, extending their lifespan and maintaining their efficiency. However, it's important to remember that they can't catch tiny bacteria, viruses, or dissolved chemicals that are invisible to the naked eye. That's precisely where carbon filters come in to play a crucial role. Activated carbon is a specially treated material that has millions of microscopic pores, creating a vast surface area. These pores act like tiny traps that capture and absorb unwanted chemicals like chlorine, pesticides, herbicides, and volatile organic compounds, VOCs. This process significantly improving the taste and smell of your water. Carbon filters are exceptionally great at removing those unpleasant bad tastes and odors that can make water unpalatable. However, it's important to note that they don't remove most heavy metals like lead or mercury, nor do they eliminate germs and bacteria effectively. Therefore, neither filter can handle everything on its own, each has its limitations. That's why they're so often used together in a complementary fashion. Mechanical filtration, combined with carbon filtration, makes water look and taste significantly better, providing a more enjoyable drinking experience. But remember, this is just the start of the water purification journey. For real, comprehensive safety and the removal of a wider range of contaminants, we need to explore more advanced methods. That's precisely why multi-stage systems are designed. These systems cleverly combine sediment and carbon filters with a variety of other advanced technologies to achieve superior water quality. Each stage within these systems is carefully designed to target different contaminants, ensuring a more thorough and effective purification process. This multi-layered approach provides a more complete solution for clean, safe, and great-tasting water. So, with the basics covered, let's move on to the next level of purification and explore some of these advanced technologies. Are you ready to delve into some high-tech water science and discover the cutting-edge methods used to ensure our water is as pure as possible? Now let's talk about ultraviolet, or UV purification. Instead of filtering, UV uses powerful light to destroy germs in water. The UV lamp zaps bacteria, viruses, and parasites, scrambling their DNA so they can't make you sick. It's chemical-free and doesn't change the taste or smell of your water. But UV only works on living organisms. It can't remove metals, chemicals, or dirt. That's why UV is usually the final step, after filters have cleared out particles and chemicals. Clean, clear water flows through the UV chamber for a final germ-killing zap. UV is a fantastic finishing touch for safe, fresh-tasting water. Let's see what happens when we need to remove everything, even dissolved solids. Meet the powerhouse reverse osmosis, or RO. RO uses high pressure to push water through a superfine membrane, blocking almost everything except pure water molecules. It removes up to 99% of dissolved solids, heavy metals, chemicals, and even some germs. That's why it's used to turn seawater into drinking water. The downside? RO creates wastewater. Several gallons may be wasted for every gallon purified. It also strips out healthy minerals, making water taste flat. Many systems now add minerals back in for better taste and health. RO is incredibly thorough, but it's best used with pre-filters to protect the membrane and improve efficiency. For the purest water, RO is hard to beat. But is filtration the same as purification? Let's clear that up. Filtration and purification. What's the difference? Filtration removes larger particles and some chemicals, making water look and taste better. Think of sediment and carbon filters. They strain out dirt and reduce chlorine. But filtration alone doesn't remove tiny germs or all chemicals. Purification goes further, eliminating at least 99.9% of contaminants, including viruses and bacteria. Methods like RO and UV meet strict safety standards and make water microbiologically safe. The best systems combine both filters for the big stuff, purifiers for the invisible threats. Filtration cleans water, purification makes it truly safe. For the healthiest water, use a system that does both. Now let's look at why this matters for the future. Clean water is a global challenge. Billions still lack safe drinking water. Urban areas face extra risks from old pipes and pollution, making home purification more important than ever. As technology improves, water purifiers are becoming as common as refrigerators. People want control over their water's safety and taste. From simple filters to advanced RO systems, these tools empower us to protect our health. In the future, pure water at home will be a necessity, not a luxury. The science of water purification gives us peace of mind, one glass at a time. Thanks for joining me on this journey to cleaner, safer water.